Hello guys, our project Detector stress. So firstly we have some audio data, audio recordings and a new folder for our result and prediction data which will help in predicting the values. Okay, next we have some models. We will use emotion voice detection model mostly, and first start with single input in which we have 60 inputs. So first start with single inputs. Here we have imported some libraries which are beneficial for our project, that is matplotlib, librosa, keras, and TensorFlows, etc. So let's run the project. Here we are just importing our libraries, just that's it. And here we are sampling our data from actor audio, which audio file that named us. And here we are just displaying our audio file with the wave plot. Just run, see, it's running. And here we will create a sci-fi wave file like this, and this part of code will tell us the loading time which takes to load the data. It's running. Okay, here is our output. It takes some 6 point some seconds, and here we will create our x and z, our elements, which will help us to plot the graph. Okay, here we have imported numpy again for the shape. Here the output, and here we are just um, loading our model from these part of codes. Now we will make the decision tree. It is a table that will tell us the precision, accuracy, and etc. etc. Now it's time for our next step, that is random forest. We will create a forest for training our data. Just see, it will find the vectors x train and y train. It's taking some time. Okay, here is our output. Okay, we have max depth 10, max features log 2, max leaf node, that is 100, and it will split into 20 samples and 3 sample leaf minimum. Okay, next we have to predict our values. So for prediction we are using this. It is the prediction table. Now we have to create our the CNN model uh, to train our data. So it's creating. Okay, our shape is decided for CNN. Now some more libraries that are TensorFlow, NumPy, Matplotlib to create our model that is sequential. Okay, let's run. So it is in it. Model summary is this. That is COVID, convert, activation, dropout. So it gives the parameters that is trainable or non-trainable. So we have 87,944 parameters and all are trainable. So let's fit the model. So it will take time because we have 1000 epoch. Okay, so it will take time. Next we start. Once it will get closed, means once it will get done, we will plot the graph for our loss and accuracy. So this is for loss, model loss. So it is telling our training data and testing data for the model loss, and same for model accuracy, but and now the predictions. Okay, here we have to wait. Okay, it's done. So let's run this part of code. Here is our loss. So as we have made a graph of model accuracy and loss, so we have to predict. We have to make some predictions. So it makes a prediction. So let's start. It prints our prediction that is an array of types in 64 y-test, and then new y-test will be in it in this, and next our y-test, and next our report, precision report after training the model, and it will show the confusion matrix which will help in detecting the emotions or sentiments of the actor. 0 for neutral, 1 for calm, 2 for happy, 3 for sad, 4 for angry, and so on. Here is our matrix. Next, we will save our model in this path. So our model is saved at this path. Now we will test again our model. That will tell our model summary that how many params are there. So it is same as we have earlier. So we will find the accuracy of our model, and it's telling 61.11. Earlier it was 72.22 something. Next, we will start with our actual project that will detect the stress from all the data set given. So, firstly, it's all about importing the libraries. Next, we will read the data from our audio speech, and here are the list who are means which audios are there. So all these have 60 audios in each folder. Next, we will create a data frame. Okay, let's start importing. Here it is imported, and we will read the data. And here is our data, like how much data we have. We have 24 folders with 60 audio each. Now let's create a data frame. So it will create a data frame. We have two genders, and we have intensities. So it will locate the path, count the path, source, actor means which actor is a folder name. Okay, and next, gender, intensity, statements, repeat, and emotion. It will detect this. Means it will count the data. Now we will have 1440 datas, and means 1040 heads of which have 5 data. So here are 24. Okay, 25. And it detect the path, source, actor, gender. So here are all from the first folder, that is actor 1. Here intensities are given, statements are given, emotions, etc. Now we will form the waveform and spectrogram. So first we will take our samples. So let's take. So it has taken about this folder, that is actor 18, and it has this array. Okay, let's take the length of the sample and sample rate. We have this. Now we will form a function for spectrogram. Okay, sample rate is given. Now we will form the waveform. First waveform, then a spectrogram. So it is our waveform and it is a spectrogram. Look at this. It is from data actor 18 and there is file. Okay. Next we will found mean of this spectrogram to create a spectrogram mean. So it is done. Now we will trim the voice with the Librosa effect trim, which will trim our data. Next we will plot our spectrogram. Now we will plot our MFCC, that is this. Now we will take the sample from original sound. We have
Kids are talking by the door.
now the trim sound. Trim sound from the Rosa effect, and we have trim sound from manual trimming. Okay, so we have two sounds audios. here it is showing that male none, female none, male calm. None means neutral. Okay, so here our label for our data. Okay, now we will plot our emotion distribution. So it is shown in a bar graph like this. Main and here are emotions and here are count. Now we will split our data. The whole data will split into this form. We have about 50. Now we will run it. So here rows and 9 columns. Now we will analyze our data from using the rules sometime. Next we will set our data. Okay, next we will label our data. We will create a new data form, data set. So here are the heads. Now we will start data processing. Like we will plot the audio frequency, add the white noise or random shifting, stretching the sounds, which our audio needs. We will do with with the help of this particle. So next we will take the sample rate which I have taken, which audio has taken. It will come up with these features of the Busa, and then it will work. So here are audio raw waves. Now next audio. Okay. Now we have two audios, so there are two data making
save the model and .json file. Okay, the new folder which I have told that it will save our model after training. So it will save the model by JSON file in this folder. Now we